Hi everyone, welcome back. And today what we're going to be going over is section 1.5. And 1.5 is applications of linear equations and modeling. So let's recall that section 1.4 was linear equations. And we discussed two different forms. We talked about the standard form. So let's just review, which is ax plus by equals c, where a and b are non-zero. We also talked about the slope-intercept form, which also is represented by a line, is y equal mx plus b, where m is your slope and b is your y-intercept. And in this section, we're actually going to be elaborating a little bit more on linear equations and how we do certain applications and modeling of these linear equations. And to begin with, we want to start by defining a new form and a new type of formula that will also represent a line. And that is called the point slope formula. And that is y minus y1 equal mx minus x1, where your slope is given and a point on the line is given. So we're going to write that equation of a line. So on that first part, it says, use a point slope formula to write an equation of the line having the given conditions. Write the answer in slope intercept if possible. So we already know a point x1, y1, and we know the slope is 2. So we do y minus y1 equal mx minus x1. We're just going to apply what we learned. And we are substituting x1 and y1 and m, our slope. So it's going to be y minus y1, which is a 2, equals m, our slope, 2, and then x minus minus 4, okay, by substitution. And then once we substitute, this is going to become y minus 2 equals 2x plus 4. And our goal, now that this written as a point slope form, our goal is to write it as y equal mx plus b, which is the slope intercept form, because that's the instructions. So in order for me to do that, I'm going to distribute the 2. It's going to be y minus 2 equals 2x plus 8. And then the only step I'm missing is adding 2 on both sides. And then this will be y equal 2x plus 10. And this is the standard form of the y-intercept form. So this is the slope-intercept, which is what we wanted. Now that we have it in slope-intercept form, I'm ready to graph. How do I graph this? I begin by plotting my y-intercept. The y-intercept is my 10, or 0, 10. So I'm going to go up here. And then my slope says m is equal to 2 from the original. So 2 over 1, that means rise over run. I'm going to use a pink, so that means up 2 over 1, up 2 over 1. So this point corresponds to 0, 10, 1, 12, and then 2, 14. And then there's my line right there. And this has an increasing slope, like so. Okay. Very similar. We're going to do problem number 2. So hopefully it's making sense. Again, we begin by labeling our points and writing it as y minus y1 equal m x minus x1. Remember, this is the point slope form because that's what we're given, a point and the slope. Now we're going to go ahead and do a substitution, and then y minus 0 equals negative 2 over 3 from my slope, x minus 5. So let me make this cleaner. Now this is just y equal negative 2/3 x by distribution plus 10 over 3. Notice that this is already in slope-intercept form. And we begin plotting this. So our y-intercept is 0 10/3. We didn't have to do a lot because the y minus 0, that was nice. So 10/3 is the same as 3 1/3. So that's roughly 1, 2, 3 right here. From this point, we're going to follow our slope that says -2/3. And that means down 2, run 3. So that means down 2, so 1, 2, and then, so from this one, so I'm going to bring this, so this is like roughly 1 1/3, and then here at 2, and then 1, 2, 3, right there. So -2 and run 3. So then that would mean that I went down from 10/3, 6/3. That's 4/3. And then I went down from 0, from 3 1/3, I went down my y-intercept. And then when I do my equation, there is my y-intercept. And then if I go down on my y is 4/3, and my x will be 1. So it's going to go down 2, run 3, sorry. So this is 3. So down 2, run 3. So this is 3 4/3, and then this is 0, 10/3. And there it is. And how did I get that? Because my height becomes now 4/3, and then my run is 3. Okay, so then that is our graph. What happens if I have number 3, which I don't have? I have 2 points, but I don't have the slope. That means I would have to first find the slope. The slope is y2 minus y1 over x2 minus x1, which I have. If we are not given the slope, then we need to find the slope. Here we do our substitution, 1 minus a -4 from substitution, and then -2 minus a -1. That's going to give us a 5 because I have 2 additions here, 2 negatives, gives me that addition. This gives me also another addition, but this is a -1. So my slope is actually -5. And I have a point, and then you want to pick. Well, what point do you want to pick? I want to pick the easy one, which only has one negative. So I'm going to do y minus y1 equal m x minus x1 now that I found my slope. I'm going to do a substitution, which is y minus the ones that I chose equal -5 x minus -2. And then I clean it up. Y minus 1 equal -5. That's a plus. A 5x plus, this gives me a +2. And then this gives me a -10. So then I add every one by 1. So I get y equal -5x minus 9. And this is exactly the equation in slope-intercept form. Again, we begin by finding our slope and then picking -1, -2. So -5x and then -10. Add both sides by 1. So that means I have to start at my y-intercept, which is equal to 0, -9, which is all the way down here. So I have, and this I'm going to plot in Desmos because I don't have room. So when I plug it in, I know it's going to go all the way down let's say down here to -9, and then my slope is -5/1. This means down 5, run 1, or we could say rise 5 to the left 1, which is the same. So I'm just going to go up 5. So this is at the point 0, -9, and then I'm going to go up 5. So 1, 2, 3, 4, 5. So if I'm down here, so this would be 6, it would be -6, -7, -8, -9. So this would be my starting point right here. And I go 1, 2, 3, 4, 5, and then to the left one, and then 1, 2, 3, 4, 5 to the left one. And that would be my equation of this line. Let's see if I want a ruler. Oh, I want to get rid of the ruler. There it is. Okay. So I said depth 5/1, up 5/1. And then there's my line. It's a negative slope, so it's going to go this way. And I should be intersecting, so this point right here. So this is also, this is -2, 1. This point is -1, -4. And this one's 0, -1. So then you could say up 5 to the left 1, and then 5. So rise, but it's still, notice how it's still a downward slope. We have a downward slope because my slope is negative. So that's something new. And then here, the next one for my graphing is it passes through the point 2, 3, and the slope is undefined. So if my slope is undefined, we've learned that corresponds to a vertical line. X equals, in this case, 2. How did I get 2? Because that corresponds to the point 2, 3. So I'm just going to go right here, 1, 2, put a point, and then there it is. This is a vertical line at x equal 2 and your point 2, 3. This is a point 2, 3. And then here, there's no way of a y-intercept form, of the slope y-intercept form, because we have an undefined slope. And we learned that because we know that the definition of a vertical line corresponds to an undefined slope. Okay. Now that is in regards to graphing and slope-intercept forms. We are going to gradually move on to what happens when slopes, what happens with parallel and perpendicular lines. There's a special case when the lines are parallel and have matching slopes. This is key on M1 and M2 of two non-vertical parallel lines. So we're not talking about two undefined slopes, but when we have two of the same slopes, that corresponds to parallel lines. So when both M1 and M2 of different lines have the same slope, then those lines are parallel. If they are perpendicular, they're negative reciprocal slopes. What does that mean? That means that M1 times M2 is equal to -1, and that's what I'm actually going to show you. This one says M1 equals -1/2 of M2. You could do that, or multiply and punch a negative. and punch a negative. So I'll show you how that's done. So see how this one's flipped. M1 equals -1 over M2. So you multiply a negative and then you flip it. So we'll start with a parallel. If we're given M, how would we know what would be the parallel slope? Well, the same value, -3/8. What about a perpendicular? Well, if M is -3/8, the perpendicular would be M is equal to flip it. So you flip it. So it's flip, and punch a negative. So I'm going to flip it first, 8 over a -3, and then I'm going to punch a negative. So then that would make it 8 over 3 because you flipped it and then you punched a negative. Okay. Now, same, a parallel would be the same identical slope, M1 equal M2. And then how would I flip a 20? Well, we know that M is equal to 20 over 1. So then I would flip it. So this M would be now 1 over 20, but then you punch a negative. Punching a negative means multiplying by a -1. So the perpendicular slope of 20 would be -1 over 20. That would be the perpendicular slope. Well, what happens when you're parallel to 0? So this would be the same, 0. And then, well, we know M is equal to 0 over 1. What would be the reciprocal? You flip it. So you would be 1 over 0 and then punch a negative, which is an undefined slope. You'll have an undefined slope. Okay. So now that we have an idea of how parallel and perpendicular slopes work, we're ready to do some examples. Give the equation of a line that passes through the point. So we have the point -1, 2, and a parallel to y minus 3x equal 4. Well, the first thing is we're going to look at the equation that we're given, and we're going to find the slope. Because what we know is that when something is parallel, they have the same slope. So I need that. So I have to write it as y equal mx plus b. So it's y equal 3x plus 4. So I know that the slope of this line is a 3. So I'm going to use the slope, and I'm going to use the point. And then I'm going to find myself a new line from that information. So I'm going to use a different color, and I have y minus y1 equal mx minus x1. This is a point slope that we learned. Then we're going to do a substitution of y minus 2 equal m, which is 3, x minus a minus 1. We get y minus 2 equal, becomes a plus 3x plus 3. And then we bring the 2 over, y equal 3x plus 5. So this is the actual line passing through the point -1, 2, and it's parallel to the one given. And it makes sense because 3x plus 5, 3x plus 4, notice that they have the same slope. They have to because they're parallel. Very similar, but now with the differences now perpendicular to a line, we want to find the slope of the original. 2y plus 5x equal 10. We start by bringing the 5x over, -5x plus 10, and then divides everything by 2. So I get y equal -5 over 2x plus 5. So the slope of the given, is -5 over 2. But is that the slope that we're working on? No, because I want to find the perpendicular slope. So what do I have to do with the original? I have to flip it, so 2 over -5, and then punch a minus. So it's going to be -2 over -5, which is 2/5. That's the slope that I want because that will make it perpendicular. Now that I have the slope that I want, I'm going to be able to use the Poinsot formula again and actually find that equation. So it's going to be y minus y1 equal mx minus x1, where I have my point x1, y1 from up here. So I have y minus 8 equals 2/5 right here, my slope, x minus 6 right there. And then I'm going to clean it up. Y minus 8 equal 2/5 x minus 12 over 5 by distribution, like so. Multiply fractions by multiply by the numerator. And then last piece, we bring the 8 over to both sides. So we get y equal 2 over 5 x minus 12 over 5 plus 40 over 5. How did I put 40 over 5? Because I want to combine the 8 and the -12 over 5. I multiply top and bottom by 5, combining LCD, so it's y equal 2 over 5 x. And then here, of course, I'm going to get a positive 26 over, sorry, 20, 28. One second here. Positive 28 over 5. And this is the equation of that line. Okay, so that 40 over 5 comes from this 8. So 2/5, and let me make this nicer. 2/5 x plus 28 over 5. And then there it is. There we have it. And that's the equation of a perpendicular passing through that point. So then what we're going to be doing is we're going to continue creating linear functions to model data. So I'm going to pause it right there, and then we are going to continue.